Hello, the penultimate video. We've made it to D5, extreme heat. So we're going to look at the conditions, what makes it extreme heat rather than just a bit hot, the symptoms that the body will show, adaptations that the body can make, and the impact that it has on our performance. So extreme heat is classed as 40 degrees or higher. That's a really hot holiday for us. Hyperthermia is when our body cannot lose that excess heat and our core body temperature starts to rise, and above 40 can be catastrophic. It can lead to death actually. So it can be fatal. There is a race called the Marathon des Sables, which you can see them running in behind us there, which is an ultra marathon in the desert. So they're running in hot and actually dry conditions in this case, in excess of 40 degrees or higher. We've talked a lot about Everest as well, and parts of that actually, as well as being altitude. On the Kumba Icefall, you can reach temperatures of over 50 degrees because you're so close to the sun as well. Hot and humid conditions are the worst type of conditions for us. It's the hardest way to get rid of our heat, which we will explain in a few slides. And it reduces our performance, first of all, by dehydrating us at a much faster level than we would do in normal heats. We get reduced blood flow to the skin, so we're not as effective of getting rid of our heat from the working muscles. So symptoms we would feel with hyperthermia. We are going to get excessive sweating, although you may not notice if you're in a very hot condition here, when we would sweat across the skin there, the heat is taken away very quickly into the dry air. We'll talk about that in a minute and how that happens. Nausea, so the body can start vomiting or at least make you feel sick. Headaches, dizziness, hyperventilation, that shortness of breath but increase of breathing rate. Exhaustion, and some of you may have suffered with heat stroke when you've been on holiday, and if you have, you've probably felt all of those things above, and it really isn't a nice feeling. It can make you feel like you've got the flu. So with these responses, you can tell already it's not going to be conducive to a good performance, or certainly for good training. So let's have a look at dehydration then as part of hypothermia. As sweating becomes excessive, and it will do because the body is desperately trying to lose its heat, and that's how it does it, or one of the ways in which it does it, we're going to lose water and electrolytes. Now this water is going to reduce blood flow. It's going to make our blood thicker, so it's not going to be able to deliver oxygen quite as well as it did before. It's not going to be as effective, and actually our heart has to increase in its heart rate to compensate for the slow movement of the blood when we're dehydrated. Electrolytes are the salts that we require for muscle contraction, like calcium, for example, sodium and things like that. So if we're losing those, it may lead to cramps in our muscles, but certainly less effective muscle contractions. When the water output, the sweating and the water vapour as we're breathing out, exceeds the amount that you can take on board, you will be dehydrated. So if you're asked what is dehydration, it is when water output exceeds intake, and due to sweating and excessive water loss and electrolytes, and it leads to a deterioration in muscle contractions. It's actually a 3-point answer. So we've got reduced blood plasma, and this is all to do with the blood flow up here, leading to decreased blood volume, and we've got salts and electrolytes have been reduced, which has a direct impact on the muscle contractions. The symptoms then, we've got tiredness, grumpiness, so irritability, possible fainting due to the low blood pressures with a reduced blood volume, and muscle cramps. So all of which, any of which, are going to deteriorate your level of training and your level of performance. So the body can adapt to heat, which is really amazing actually. It can take about 1 to 3 weeks to adapt. And the body actually starts to preserve the electrolytes, so it knows it's losing them when you're sweating excessively, and it tries to preserve them. It doesn't try, it stops you from sweating some of those electrolytes out. So sodium and chloride that are needed for muscle contractions can be preserved. You really should know the names of those two electrolytes. We get increased blood plasma, which means that we don't lose the blood volume. So this is really important because it keeps blood flow up. If we're keeping blood flow up, we're keeping oxygen delivery, nutrient delivery, and the removal of carbon dioxide, which is essential, as we know, for aerobic activity, which is what these guys are doing here. There's an earlier onset of sweating, so it doesn't wait until it gets to the temperatures it would do over here. It starts earlier on than that. It's almost like it knows what's going to come up, so your sweating system is more effective. That means they can keep the core body temperature lower for longer, which means that you can work at higher levels even in the heat. So can you explain how the adaptations impact the body's core temperature? If you pause the video and write yourself out a paragraph to explain. Here's a sample answer for you. So you may have mentioned that the adaptations happen between 1 to 3 weeks. You may have said there's preservation of electrolytes, and I would have liked you to name sodium and chloride. And then you've said that this makes dehydration and cramps less likely, so you've done the impact of that. You've said there's increased blood plasma and therefore increased volume of blood. So there's less stress on the heart, so that heart rate doesn't need to increase because of the lack of blood flow, because you've got efficient blood flow for the delivery of oxygen and the removal of carbon dioxide. You have an earlier onset of sweating to lower the core body temperature. You have more effective body systems to get rid of heat. So therefore the impact is that you can work for higher intensities and longer durations in that heat. That's it, another video done.